And we are very, very lucky to have Vera Schwartz as our keynote talk, which follows very nicely after our panel on large language model and creativity. So we're going to find the answer of did large language models solve figurative language at the end of her talk, hopefully, or we might still be without an answer. But first, let me introduce Vered. She is an assistant professor at University of British Columbia in computer science. And she has been leading a lot of breakthrough research in common sense reasoning, semantics, pragmatics, multi-word expression, and she has been doing a lot of work in figurative language. Before joining University of British Columbia, she was a postdoctoral researcher at Allen Institute for AI, and she obtained her PhD at Bar-Ilan University. Her work has been recognized by several awards, and I'm going to mention some of them. She is the recipient of the Eric Wendy Schmidt Postdoctoral Award for Women in Mathematical and Computer Sciences, the Clore Foundation Scholarship, and she was also the recipient of Outstanding Award at ACL 2016. So without further ado, Vered, we are very happy to have you here.
Yeah, thanks, Mara. Thank you very much for inviting me. And yeah, I have a quick confession about the title of the talk. The organizers asked me for the abstract and the title way before I made the talk itself. So I gave a very generic title, and I hope the answer is not going to be disappointing. So, okay. So as you all know, figurative expressions such as idioms, similes, and metaphors are ubiquitous in English. And for many years, they have been considered as pain in the neck for NLP applications, partly, or for one of the reasons is because they have this like non-compositional nature where you can't understand their meaning or like straightforwardly understand their meaning from the meaning of the constituent words. So now with large language models excelling at generating English text, it's time to ask whether they solved figurative language. So here's a recent example, just as a motivating example. I asked ChatGPT to make up a short story. I will not read it out loud because it's very long, as ChatGPT generated stories usually are. But I did highlight a few of the many figurative expressions in this story. So we have like a metaphor, like the key to a forgotten realm, and then some like more common metaphor, like journey, meaning like not like a physical journey, but like a process, and embracing her destiny. To say that LLMs solved, and again, I'm going to use air quotes when I say solve because it's not clear exactly what it means to solve it, but I'm going to look at various aspects. So the first one is going to be whether they can recognize figurative language. Then the second one is going to be whether they understand figurative expressions, and understanding would be both in and out of context. And the third question would be whether they use figurative language in generated text. So we kind of already answered three, but we will go back to it at the end of the talk in more depth. So let's start with detection. I have worked on figurative language, but pretty like sparingly recently. So there was going to be some results in the talk that are old, very old by NLP standards from like 2019. So I will have like in the upper left corner of the slide, I'll just put the year of the findings so that we know if it's likely still relevant or not. Okay, so the first thing that we want models to be able to do is to recognize figurative expressions. So for example, in this news headline, furious Meghan Markle says she won't fall for dad's crocodile tears after he claimed she'd be better off if he were dead. Then in this case, we want to know that crocodile tears is a figurative expression. It's used figuratively. It's not actually about crocodile and not necessarily about tears even. In 2019, we had a paper where we tried to address this and other related questions with a probing task. And specifically, we focused on this non-compositionality aspect and specifically for noun compounds. So, for example, we had a sentence with a noun compound, like the crash course in litigation made me a better lawyer. And then we wanted, given a single constituent from this noun compound, like crash, we wanted to recognize whether it's used literally or non-literally. And so we probed many models for this capability by embedding the sentence and then training a classifier on top of these frozen representations. And yeah, this was old work. So at the time, we only tested BERT, GPT, and Elmo as our contextualized representations. But the answer was already absolutely. Models can recognize when a word is used non-literally. And if you think about it a little bit, it's a relatively easy task because it's sometimes enough to recognize this semantic incongruity. And in this case, detecting that a word like crocodile appears in this headline that has nothing to otherwise do with amphibians. Here's a similar task. This is from the Magpie corpus from 2020. In this task, they required recognizing whether a certain phrase is used figuratively or literally in a given context. So, for example, the phrase "add fuel to the fire" can be used. It's a figurative expression, but it could also be used literally in some contexts. So, in the first context, 10 minutes later, when silence reigned from the other side of the flames, she set up and add more fuel to the fire. So this is actually literally adding more fuel to the fire. Whereas in the second sentence, it seemed the quarrel would finally be talked out when Mark added fuel to the fire by bringing up the question of who was guilty. So this is the figurative usage. So there's a very recent archive paper that tested models on 3 such data sets. The Semival 2022 Task 2A, Flute, which I think I'll discuss a little bit later as well, even though you probably know it very well, and Magpie. And they found consistent improvements with model size. So the bigger the model is, the better it was on this task. But they also showed that zero-shot and few-shot models, even GPT-4, which is like the gold standard these days, still lagged behind the fine-tuned models. And then, oh yeah, I should have mentioned this paper is from Aline, who's here. Yeah, I think I'm going to cite a lot of you people in the audience. Okay, another way to test models' ability to detect figurative expressions is through classification to types, like is it an idiom, simile, metaphor, sarcasm, etc. So there's a recent CL paper from the Young's group that tested models on this task. And they found that models had mediocre results on this classification task. And in particular, GPT 3.5 and GPT 4 performed especially worse in the zero-shot setting. So we're kind of seeing a pattern. So to recap the first part, detecting that a phrase is used figuratively should be a relatively easy task. Maybe in context it's a little bit harder. Sorry, maybe, yeah, okay, not always, but sometimes it's enough to detect incongruence between the phrase and the rest of the context. Fine-tuned models seem to do very well. It's unclear whether they do well because they learn good incongruence features or whether it's because they learn bad spurious correlation features. I don't know if there has been work to study that. And there are mixed results for LLM in prompting setups. And in particular, it seems like despite GPT-4 being really good at literally any other task presented in this conference, it's not really good at this kind of task, like recognizing or classifying figurative expressions. So let's look at understanding. So for a person, presumably, if to be able to, if we understand a figurative expression, then that necessarily means that we're going to be able to recognize that it's used figuratively. And so let's see how models do. Okay, so going back to this example, and so in this headline, let's say that a language model or a person reading this headline doesn't know what crocodile tears means, then understanding the meaning of the idiomatic phrase is a bit trickier than just detecting that, yeah, this doesn't seem like it's actually about crocodiles. If for a language model or for a person to try to interpret the meaning of this phrase, they would have to do that from the context in which it appears. And in this case, they will need to understand the story, maybe have some prior knowledge on the characters and the relationships. Like in this example, yeah, she fought with her father. He like staged, this is an old example. He staged this like paparazzi shots before her wedding, and then she said, I think she uninvited him from the wedding or something, and it was a whole like public story. And if you don't know that, maybe it's not really easy to try to understand what crocodile tears means. Oh, sorry, I have it in the slides. Yeah, so yeah, he staged the paparazzi shots of him preparing for the royal wedding, and they fought about it. She asked him not to attend the wedding. And then you might also want to be able to, you might also need to make some common sense inferences that like, because of what happened, he was probably hurt. And that people sometimes when they're hurt or when they want to get something from other people, they emotionally manipulate them. So from that, you can understand that this is some sort of like a non-genuine expression of sadness that is like manipulative. So in that paper in 2019 that I mentioned earlier, we concluded that models were not good at learning the meaning of idiomatic expressions, because at the time we said that, yeah, that would require world knowledge and reasoning abilities that, at least at the time, were beyond the scope of the models. And in that same paper, we had a very like anecdotal analysis where we used masked language models to in that task where we recognized that a specific, like a certain constituent word is used non-literally. We use the models to the masked language models to find a substitute for that word. And so, for example, in a sentence like the Queen and her husband were on a train trip from Sydney to Orange, if you replace the word trip that is used literally here, you get most of the substitutes were correct. GPT-2 was specifically not good on this task because it was unidirectional, but Bert and Elmo were very good. But then if you do the same thing with an occurrence of the word trip that is figurative, like guilt trip, then a lot of the suggestions by the models were actually incorrect. And so based on multiple examples that we tested, we hypothesized that models were not as good at interpreting non-compositional noun compounds as they were at recognizing that a word is used non-literally. But I would hedge a little bit, and I would say this is a little bit of an unfair test, because it's not clear that there's always a single word that can replace one of the words in the noun compound to make it a literal and understandable noun compound. Sometimes you have a phrase like snake oil salesperson, where like you have it's both words are used non-literally. And so here now I'm citing another person in the audience. So a better way to test understanding was suggested by Tuhin in 2022. This dataset Flute focused on sarcasm, simile, metaphor, and idioms, where each instance was a pair of a literal premise, like everything is heavy, and a figurative hypothesis, which may be either entailed by or contradicted by the premise. Like, for example, everything is like a snowflake touching skin is contradicted by everything is heavy. And they also had explanation generation in this task. So in this case, the explanation why it's contradicted is that snowflakes are very light. So if everything is like a snowflake touching skin, that would be light and not heavy. And I mean, if you attend this workshop regularly, you probably know this task because it was the shared task in the previous iteration of this workshop. And so I tried to find recent results on this data set, and I found this. So this is again from this CL paper, and it wasn't exactly in the setup of the task because they had this, like, they used they did like a classification task for the types of the figurative expressions, but they did work on the explanation task. And so they showed that despite the model's mediocre performance at on classifying expressions to type. On the explanation task, humans judge the explanations from GPT-3 and GPT-3 and a half, 3.5, and GPT-4 as very good. So that's interesting. And so the explanation task is somewhat similar to asking a model to define explain an expression in context. So I recently, again, went back to this example with Meghan Markle and asked ChatGPT to explain this example. This is what it generated. And again, ChatGPT outputs are very long, so I'm not going to read all of it, but it did highlight some important details here. And so it not only understands the meaning of crocodile tears, but it also interprets that in the context. So it says that Megan is expressing anger and skepticism towards her father's recent actions. And then I think actually some of the details that ChatGPT shares here might be actually based on knowing that particular incident and not just from this context. So I didn't notice that before. But then it goes on and defines crocodile tears as insincere or fake displays of emotion. And it even cites its origin as like, where is it? Yeah. From the ancient belief that crocodiles shed tears while eating their prey, creating the false appearance of sorrow. So that's impressive. And so we can ask whether ChatGPT is relying with its familiarity with this very common idiom or whether it's actually making sense of figurative expressions on the go. So my hypothesis is that it's likely both. And I don't have a concrete answer, but I can mention there was this work last year at the ACL from Adi Chaviv. And she showed that LLMs memorize idioms, and that she actually specifically, it was not, idioms were the means here, not the goal. She chose idioms as like fixed expressions to show the extent that LLMs memorize. And so she tested BERT and GPT-2 and showed that BERT memorized between 28% to 38% of the idioms, and GPT-2 memorized between 45 and 48%. And she showed that by showing a model the beginning of the idiom in multiple different contexts and then seeing how often it predicts the next words. LLMs are not only able to accurately guess the next word in the idiom regardless of context. As we just saw, they can also provide definitions of idioms. But this is also not surprising because they're trained on essentially all the text on the web. And so they're also trained on these websites that intend to teach non-native English speakers about weird idioms that we don't know. And so they have been specifically trained on these definitions. We know that. And so when I Googled part of the crocodile tears explanation by ChatGPT, I found high overlap with this tweet specifically that described it as insincere or fake displays of emotion. And it also cites the origin and using different words, but it's definitely in the data. Last year, we had a paper at Findings of ACL where we showed that we were working specifically with GPT-3 at the time, and we showed that it was able to interpret and define novel noun compounds such as graduation parking or chocolate crocodile. And by novel, I mean like they might not be like entirely novel, but they didn't have occurrences in the large web corpus. But people could make sense of them. So like, yeah, chocolate crocodile you can make sense of that if you've seen like chocolate bunny, for example. So these models, they were still over-relying on the training corpus, as we could identify from the errors. Like, for example, GPT-3 was defining chocolate crocodile, basically ignoring the chocolate part and just like generating the definition for crocodiles. But it was still pretty good. So the only difference here from like figurative expressions is that these were noun compounds that were necessarily compositional, because we chose them as noun compounds that, even though they're rare or non-existent, a person reading this noun compound would be able to make sense of what it means. So we've seen several ways to like test understanding, and an alternative method to test understanding is indirectly, by asking the model to perform some task or answer some question that would indicate understanding the phrase in context, or at least suggests that. So this is something that I did together with Tuhin a few years ago. And so we designed this benchmark that tested models on their ability to interpret idioms and similes. I will focus on idioms here for the example, but we had an equivalent data set for similes. So we created this data set of short narratives that include idioms. So we had a list of idioms from an online, from some website, and then we retrieved 5-sentence paragraphs from the Toronto book corpus that contained an idiom from the list. So here's one example. Everyone smiles. You should probably tell your parents about the wedding tomorrow, Carmen suggests. What about you? I asked, not thinking that she'll be okay. I'll be fine. Since Dominic isn't up for grabs anymore, I figured I'll concentrate on something else, Carmen declares. So in this example, up for grabs is the idiom, and that means available or obtainable. So what we did was we took these narratives. These were like paragraphs, some stories, but they were still understandable, even though we took them out of their context. And then we asked crowdsourcing workers to suggest 2 sentences. Each of them continues the narrative. One of them should be plausible, and the other one should be implausible. And so where plausibility specifically needed to depend on understanding the meaning of the idiom. So for example, Carmen will find someone new to be with is plausible, but Carmen will continue to pursue Dominic since he is available is implausible because it contradicts the meaning of the idiom. And then we had 2 task setups. One of them was a multiple choice task where the model needed to predict for these 2 possible continuations which one is the plausible one. And then we also had a generative setup in which the model just needed to generate the next sentence, and we judged it for plausibility. So we evaluated multiple models in various setups on this task. So we have zero-shot models, few-shot models. The only difference from what we do today with zero-shot and few-shot models is that it wasn't with instructions, because at the time models were not instruction tuned. So we just showed the question and the answers, and it needed to choose them. Actually, there are several different setups here. But our best performing model, or like the supervised models, were much better performing than the zero-shot and few-shot models. And it was closer to the human performance. That was so Roberta got 82% on this task, or accuracy of 82%, which was close to, or closer than to human performance than the other models. The human performance was 92%. But we did see that it was somewhat due to annotation artifacts. So there was some superficial cues that gave away the correct answer. And we showed that by training a version of the model, like the same model, that didn't have access to the narrative, just to the continuation sentence, which would be a setup in which people would not perform well, but it still performed better than chance. So yeah, somewhat due to supervision, but also somewhat due to annotation artifacts. So yeah, I keep going back and forth between years. In the 2019 paper that I mentioned earlier, where we talked about how models are still unable to do that, to like try to interpret the meaning of the figurative expression, we proposed that future models can take inspiration from the way that non-native English speakers interpret unknown English idioms. So there was a paper from 1999 in language education that showed non-native English speakers idioms, like an idiom in a given sentence, and they basically asked them, try to like think out loud and try to interpret what this idiom means. And then they analyzed the strategies that people took. So the most common and successful strategies were first trying to infer that meaning from the context, and second, trying to infer that from the literal meaning of the constituent words. So we followed, so in that 2019 paper, I suggested that, yeah, we should probably have models that do the same. And then in the paper with Tuhin in 2022, we followed up on that idea, and we developed two supervised knowledge enhanced models. Let's look at another narrative example. Isaac yelled across the cliff, face to me. The rush of beating the tempest had his adrenaline pumping. I could see he was scared yet invigorated. Okay, man, you're up next, he yelled out to me. A sick feeling swept over me. It was indeed my turn to run the gauntlet. So our first model was the literal model. So we used a Comet model. Comet is like a language model trained on a knowledge base. In this case, it was trained on ConceptNet, which is a common sense knowledge base, and that can generate knowledge about concepts. So we took the content words from the idiom, which is run and gauntlet, and we generated knowledge about that. So for example, and it's not entirely grammatical, but run is used to get exercise or for getting exercise. And run has the property of found on gym. Found something you would do in the gym, and gauntlet is used as a weapon. And so we take these, we took the top two inferences for each of the 6 concept-net relations, and then we trained a scorer that was very similar to our Roberta baseline, but it actually predicted a score for each combination of the narrative, a single inference, and continuation. And then the score for each continuation was the sum of scores across the different common inferences. And so the model was trained end to end. We didn't have any direct label or direct supervision for the inferences, but we only had the supervision for the correct continuation. And then similarly, we also trained a context model that used a different version of Comet called Paracomet, which was a paragraph level model that could take a paragraph and reason about the causes, effects, and mental states of the participant in an event. So in this example, it tells us the narrator sweats from nerves, feels scared, and wants to feel better. So we got a small improvement with the context model and a slightly bigger improvement with the literal model. We also tried combining the decisions from both of them, but that didn't really work. And so, yeah, really small improvement. And I'll go back to this when I talk about the generative setup, because there we actually had a more substantial improvement. So because this is the paper from 2022, it's like ancient history in NLP now. And so when we have much stronger models now, so I ran some experiments for this talk. So I used GPT 3.5 Turbo and GPT-4 in zero-shot and few-shot setup. I added instructions because we have instruction tuning these days. I used 5 examples in the in-context setup. And I would also say that, yeah, for GPT-4, I was only able to test 100 examples. So it's not the whole test set. But still, you can see that the models performed much worse than the models that we had in 2022, or like slightly worse than the other few-shot and zero-shot models, which I'm not sure why, but consistently much worse than, or consistently with prior work, much worse than the supervised models. So I don't know, what do we take from that? That newer models are worse at interpreting idioms, or that supervision is important? There's a bunch of conclusions we can make. So let's look at the generative task first. And I will not go into details on the different models that we trained for the generative task, but I'm happy to elaborate during the Q&A session. This is the automatic evaluation. We also had human evaluation in the paper. And so one of the more informative, though not perfect, automatic metric was BERT score that encodes each of the predicted and gold standard continuations with BERT and then compares their vectors. And so our context model performed slightly better than the literal model, but then both knowledge enhanced models performed worse than, slightly worse than the best performing model, which was just the supervised GPT-2 extra large model. But we also did human evaluation because we know that generative tasks, like we don't really have a reliable automatic evaluation for generative tasks. So we took the outputs of the 3 models that seemed to be the best performing according to BERT score, which was the GPT-2 model, and then the GPT-2 enhanced with either the context knowledge or the literal knowledge. And then we ask the annotators to judge the endings from these three models for the same narrative. And the context model was actually preferred most of the time, which was really nice to see because it was in line with the experiments from 99, where on people that showed that the context strategy was substantially more common and more successful than the second best strategy, which was the literal strategy. I'll show you some examples. So that would include examples from the newer models and the older models. Here's another narrative. I don't know what Sally plans to do. Things were sort of messy when we talked. I'm working 50 hours a week. It's almost crazy. Let's leave this question up in the air until next week. And so the gold standard continuation, which was generated by, or like written by a person, was there is no reason to make any decisions right away after all. So if we look at the outputs from the older models, so GPT-2, which was the best performing model according to the automatic evaluation, generated this really weird string of underscores for some reason in the beginning. I don't remember if we had some like special tokens that we tried to do, but yeah, it was consistently generating weird tokens. But then it generated, I'm so sorry about this. I'm so sorry about this, but I'm going to have to stop answering questions, which is okay, not bad. Not good either, but not bad. GPT-3 zero shot generated, I don't want to be late for school, which is wrong because we know they're talking about work. Unlikely that they're working 50 hours a week while going to school. I hope so. And then GPT-3 few shot generated, Sally is trying to figure out what to do, which is okay, but like pretty trivial. It kind of like repeats what's already said in the narrative. If we look at the outputs of the new models, so first of all, before you start reading it, you can see it's much longer. So GPT 3.5 zero shot generated. In the meantime, I'll try my best to find a way to balance my hectic schedule and get a clearer understanding of Sally's intentions. And GPT-4 zero shot generated. In the meantime, I'll try to catch up on some rest and clear my head before we tackle the issue with fresh eyes. So these are really good. We don't have any evidence that any of these models misunderstood the expressions. They look pretty good. Here's another example. This one is a little bit more violent. I call it ensuring your future happiness. She scanned the park. As usual, there were uniformed police officers within shouting distance. I could call one of those cops over here and report you. Go for it, but then the paper would get wind of your bigamist marriage. And so the gold standard continuation was, and when I say gold standard again, this is human written. It's not the actual continuation of the narrative. After she reported her adversary to the police, a reporter from the paper contacted her about her marriage. So that's good. For the older models, GPT-3 again started with this like tilde for some reason, and then generated the next morning, the two of them were still sitting at the park bench. Very unlikely that this like difficult conversation with the threat continued for the whole night. GPT-3 zero shot generated. Her eyes widened in shock and she let out a tiny gasp. Oh no, I didn't. So this is not bad, but it just like cut in the middle. But that's, I guess, our fault for too small number of maximum tokens. And then GPT-3 zero shot generated. She goes to the cops and they soon arrest Andrew. He goes to jail for bigamy. So that's a classic, at least old language model behavior of like confusing two characters. Not sure about how the newer models do in that aspect. So let's look at the outputs from the newer model. So GPT 3.5 generated. The threat hung in the air, forcing her to consider the consequences of her actions and the delicate balancing act between protecting her secret and seeking justice. And GPT-4 generated. Her fingers tightened around her phone, the threat hanging between them like the sword of Damocles, as she weighed the ruinous consequences of his words. That's like, this is very good. Like these are words that I don't use. Like I'm a non-native English speaker. I don't use a lot of the words here. Very, very sophisticated. And if you suspect that this is copied from the actual narrative, or actual story, it's not. It's actually quite different. So in the original story, it's like her niece weekend, bigamy, true or untrue, even a hint of this would destroy Adam's credibility in his bid for the council nomination. Completely different. So It's very impressive. So these models are not copying the original story. So to recap the second part about understanding of figurative expressions, LLMs are familiar with many common idioms. Their language understanding abilities and word knowledge can also help them interpret unknown expressions. I mean, it seems like that. Probably better experiments are needed to conclude that. They can define and interpret idioms in context and generate text that seemingly depends on understanding the expression. But they still perform worse than fine-tuned models on discriminative tasks pertaining to figurative language, like in this example, choosing which continuation is more plausible. So for the last part, let's discuss use or generation of figurative language. So arguably, as people, if you want to use a figurative expression, we better know what it means. Otherwise, it could be quite embarrassing. And so our language models generating figurative language, we already know they do, but do they also use it correctly, or like, do they understand, or yeah. So we already saw this example from ChatGPT using many figurative expressions in this generated story. So we know models definitely generate figurative expressions. This is a very like tangentially, well, very like a not super related paper. It wasn't about figurative expressions, but while I was preparing this talk, I noticed that it was actually a little bit related. So this is a work from my student Sahithya. She worked on translating literal sentences to humoristic, and specifically she distilled a large language model to a small language model through like a teacher-student architecture plus feedback. When I looked at the outputs, almost all the humoristic outputs included some form of figurative expression, and many of them more than one. So let's look at some examples. So for the literal input, I can't wait until after work today. I get to go pick up my new car. So here are some of the humoristic outputs from our model. I'm counting down the minutes until I can ditch my rusty old ride and cruise off into the sunset in my new shiny new wheels. I'm practically bouncing out of my seat with excitement to get my hands on my new set of wheels and hit the open road. Today's workday is dragging like a rusty anchor, but I've got my eyes on the prize, my sleek, sexy new car, waiting for me like a gleaming oasis at the end of this never-ending workday desert. It's like almost excessive. So many figurative expressions. So yeah, I emphasize what I consider as figurative language in bold. I think maybe some things that I didn't emphasize might also be considered. Like there's a metonymy here, like wheels, using wheels to indicate car. So we have idioms here like counting down the minutes or eyes on the prize that are like common or known idioms. But there are also similes like dragging like a rusty anchor or a gleaming oasis at the end of a desert that might actually be novel. So yeah, I haven't done anything systematic to prove that, but I did Google that just to see if it's on the web. So dragging like a rusty anchor I found a tweet that said that. So that might be the source. Maybe it's also like used in others contexts, I'm not sure. And there's also some evidence of using oasis to describe rest after a desert work week, but I couldn't find the exact phrase. But I mean, we kind of know that models, they mix and match. They don't have to have things verbatim in the training data. So I would be curious to test the level of creativity of models in generating new figurative expressions. And I'm sorry I missed the panel. I was in a different workshop that I organized. I would like to discuss it later with people if this particular point was discussed. Okay, so and then so far there were two papers that tested the impressions of writers from AI writing assistants. Again, one of these papers is from Tuhin. These like AI writing assistants were based on language models. And yeah, they had a lot of interesting conclusions in the paper. Actually, both of these papers are really interesting, so I encourage you to read it if you haven't. But one of the like relevant conclusions here is that the authors seem to suggest that the suggestion from the LLM-based writing assistants were often cliched and repetitive. And so it is interesting because if you look at the previous slide, they're excessively using figurative expressions. It's like yeah, related to like generating cliches. Okay, so to recap the third part, LLMs generate a lot of figurative language, like really a lot, and not always in a tasteful manner. And it's not clear yet how creative they are in coming up with novel similes, metaphors, etc. And I would hedge here and say, like, I probably missed some papers about it because there's so many papers right now in NLP. But yeah, I personally don't know yet what the answer for that is. So, so what's my overall take from all these findings together? Because I had a lot of contradicting findings. So I want to claim that this seems like a case of the generative AI paradox. So this is a paper, a recent paper from AI2 that was, the first author was Peter West. And I think it was an iClear paper, yeah. So what they showed was that LLMs, they excel at generating answers, and like humans often judge these answers as better than the answers written by other people. But they're often wrong when they're tested in multiple choice settings, and even when they're tested on their own generation. Like they generated a story and then you ask them questions about the story and they provide wrong answers. So they concluded that the LLMs are better at generating and then understanding, which you can expect from their training objective, but it's a paradox because it's opposite to people. Because as people, arguably, if you want to like generate content about something, you need to first like understand it. Hopefully, you need to understand it before you write about it or talk about it. So in the context of figurative language, as we just saw, LLMs use figurative language properly. They are able to generate definitions and explanations of their usage in context, but they perform worse in discriminative tasks related to figurative language understanding. So it could be that. It could also be that maybe in general they don't perform very well on discriminative tasks, even though we have a lot of evidence from other areas of NLP where they do perform well. So I tend to think that it's this, the generative AI paradox. So to recap everything, LLMs use figurative language properly. I'm not sure how creative they actually are. They are able to generate definitions and explanations of their usage in context. Some of it is probably due to memorization. Some of it might be thanks to their advanced language understanding skills. I think it may be time to move away from known idioms to more like work on ad hoc figurative expressions like similes, metaphors, and sarcasm, because existing idioms have been in the training data for these models. They perform worse on discriminative tasks related to figurative language understanding, and we can still do some like discriminative setups, but maybe we want to switch to testing models on downstream tasks that depend on understanding figurative language, but not like directly asking them about the meaning of these expressions. Thank you, and I'm happy to answer questions.